Hi, my name is Charlie, and today my topic is water mass transformation in the Iceland Sea, contrasting two winters separated by 4 decades. And first, we have to know where does water mass change. So this is the picture of the thermal helium circulation. And the red line is the warm surface water flow, and the blue line is the cold deep water flow. And the areas here, and here are the cold deep water flow turned into the warm surface water flow. So it is where the water mass change. But there are some areas that we don't know about, just like here. If we draw the line on the ridge here, we know the south side of the line, but we don't know what about the north of the line. So scientists start to do the analysis since 1950. So after the analysis, we discovered that the potential density of the seawater has lowered, and the source of the water jets has changed from Iceland Sea to Greenland Sea. So this is the things we want from the north of the ridge. One is where and how the water mass transforms, and 2 is why the source of the water mass changed during the last 14 years in this area. And why was 1974 and 1975 chosen? Because it is the only winter that has enough data coverage of the Icelandic Sea to display changes. And how do we collect the data from 1974 and 1975? We use the data from historical hydrographic data sets since 1950, and it is collected by vessels. And in 2015 and 2016, the vessels evolved into autonomous ocean gliders. And the difference of these two data are the grids. The grids in 1974 has the length of the 1 degree longitude and 0.5 latitude. But in 2015 and 2016, it has 0.5 longitude and 0.2 longitude. And that is why we can see that in 2015 and 2016, we can see the data more clearly. And how do we fix the inaccuracy? We use the ERA 5 to reanalysis to solve this problem. ERA 5 is the 5th generation of meteorological reanalysis projects, and it is organized by European Centre for Medium Range Weather. And it can detect sea ice concentration and surface turbulence fluxes. And what is the differences between jets and currents? Jets are fast-flowing and narrow and meandering currents. So fast-flowing, which means it has higher speed for the water flow, and narrow, it is also usually located in between the ridges or above the straits. And meandering currents. This is the picture I took in Norway this March. This is took in here, the northern Norway. The sign right here says that in front of this river here, it has one of the strongest water currents, and it is written in Norway, so I translate into English. So we have the major jets in the Nordic seas, which is the NIJ, the North Icelandic jets. And the red color is the warm current, and the blue one is the light blue color, so which means the NIJ is the cold currents. And it is located here. And the importance of the NIJ is it can transport dense water, and it contribution to the deep cold seawater. And it can interacts with other jets. And the density, the most important is that the density of the water masses changes significantly during the last 40 years. And this is the picture I took in Iceland. So this is facing the northwest in the North Iceland. So this is where the NIJ located here. And why do we assume that the jet's resource changed? Because the potential density of the surface seawater lowered a lot, because we can see from here and here. The yellow line is more closer to the zero. And what is water overflow and overflow water limits? An overflow is a type of deep water circulation in which denser water flows into basins beneath lighter water. And overflow water limit is the constraints on the volume and properties of dense water masses flowing between oceanic basins. And the average of potential density of NIJ is around 27.9 to 27.95 kilogram cubic meter. And it won't change over time, so it will always stay the same. And the overflow water limit of potential density is 27.8 kilogram per cubic meter, and which means if the water mass is over 27.8 kilogram per cubic meter, it could be a source of the jets. So we can see this is the line of the 27.8. So which means over here, it can be a source of the NIJ. And what do we can see from these two figures, the water mass of that potential density is between 27.9 to 27.95 kilogram per cubic meter that didn't flow out much. So you can see it is replaced by the water mass that's potential density is between 27.8 to 27.9 kilogram per cubic meter. And so we can see that the source of the NIJ turns from Iceland Sea to Greenland Sea, because Greenland Sea has more colder water and it has more denser water mass. And what did the potential density of the water mass in Icelandic Sea change? It is because of the reduced sea ice. This is the picture I took in Iceland, and this is the glacier we can see from far away. But the guide told us that 20 years ago, the glacier are over here. So we can see how much that the glacier have reduced. And this is in the northern Norway. You can see that even in the winter, there are no sea ice. And you can see how the heat changes with the cold water between sea and the cold wind. When the wind blows from the land, the cold air would flow to the sea, so it can change the heat with the sea. And this is in 1970 to 1979. But now the sea ice reduced, so it can only change in the near sea shore. So it can only change in here, but not from the far away sea. So the sea here would have more heat than before. So the temperature would become higher and the water mass would become less denser. And the red line is the sum of the first two components of the Fourier transform represents the variability. And the periods are greater than 35 years. And this is the heat flux between Iceland Sea and the sea ice in the last 7 centuries. And the unit is water per square meter. And what does the higher heat flux means? It means heat exchanges a lot, so that the heat won't just stay in the sea. It can change with the cold air so that the heat won't just stay in the sea. And the outcome, we can see that the reduced sea ice is caused by the potential density of the seawater in winter lowered. And it is caused by the source of the water jet changed. And the things we want to know from the North Ridge are clear now. And this is the reference.